Hello, everybody. Happy day 3 of section 2.4. Benny and I say hello. Benny, can you say hello? Hello, mathematicians. How are you? We miss you, right? Yeah, Benny misses you. We miss you. So, hope you've been doing good. It's the last day. It's MEA weekend. How sweet is that? All right. So, what's the sticker say today? Here it is. What's it say? Oops. Why do you think I picked today to say oops? All right. Why would I wear this sticker? Maybe because we're waiting to see how many mistakes I make again. I don't know. All right. I thought it was appropriate, but I do have a little deep thought for you here. So here's another sticker. How to be a math person. 1, do math. Step 2, be a person. Okay, there it is. How to be a math person. Step 1, do math of any type. Number 2, or step 2, be a person. Well, therefore, you are a math person. And guess what? You are all math persons. All right. So, what are we going to do? Today we are doing basically the same thing, but what happens when we have something called special solutions? What happens when something weird happens? All right. So what we're going to do is we're going to go ahead and work through those. But like everything else, okay, there's Benny. Say hi, Benny. Benny's sitting in my lap. All right. I'm sitting outside on my patio, enjoying this nice weather. Good thing there's no neighbors around to watch me with a sticker on my forehead. They'd be wondering what the heck is he doing. Okay, here we go. So it's day 3, and of course, what do we got to do? We got to watch for Mickey Mouse. Okay, he might be hidden. He might even be in there twice this time. I don't know. We're going all out today. Number 2, how many mistakes did I make? Number 3, keep track of that in your journal. And then number 4, do the QR code at the end, right? All right, well, let's go ahead and proceed. Is this anything? Here's practice from yesterday, right? So same kind of thing as yesterday. We're going to go with green today. All right, for our color, let's go green. All right. And this is just a review real quick. You did the distribute, right? We distributed that 4 into both. So we got 8z plus 12. Benny, you're getting in the way there. Equals 12 plus 8z once I've distributed that 4 to the 3 and the 4 to the 2. And then you combine your like terms, balance it out, right? So, Benny, you're kind of in the way. He's probably looking for bunnies in the backyard. All right. Let's look on the screen. What happens if I get a problem like this? All right, well, nothing different. We're going to continue to do what we normally do. 5y minus 2y. I have 5 yolks minus 2 yolks. Why yolk? Because yolk starts with a y. I don't know. And we get 3 yolks, right? 5 minus 2 is 3 equals 3y plus 2. I go to subtract 3y minus 3y minus 3y. That cancels and that cancels, and that leaves me with 0 equals 2. What? How is that possible? 0 equals 2. I got to put you down, Benny, because this is intense. Because when does 0 ever equal 2? How about I give you $0 if you give me $2? Is that fair? I don't think so. So 0 never equals 2. This is never true. So what happens is some people look at this and go, well, then we must have made a mistake here doing our math. And that's not necessarily the case. When you get sometimes where these variables cancel out like they did, and you get something where they're 2 different answers, then we have something called there's no solution. No solution. That's where we're dealing with solving equations that have no special solutions. And in this case, there is no solution. What does that mean? All right. How can you come up with all this math and we've been working on it and all of a sudden go, well, there's no solution? It's because I will never find a number that I can put in for y that makes this side of the equation and this side of the equation the same. I will never find a number where that's true. And why? Because look at this step right here. I'm going to rewrite it. 3y equals 3y plus 2. Is there any time when 3y will equal 3y plus 2? Never. They will never be equal. So an equals with a line through it means not equals. Okay. So we say there's no solution there. All right. And I'll come back at the end and summarize these answers. All right. Let's try this one. Okay. Same thing as yesterday. On the left side, I can't do anything. So I'm going to just rewrite 5x plus 5. On the right side, I'm going to distribute. 3 times 5 is 15x. 3 times minus 4 is negative 12. Right? Or shishing it. If I shishing it, 3 times a negative 4 is a negative 12. This 10x, bring down, but don't forget to bring the minus with it. Right? On the left side, I get 5x plus 5 equals. On the right side, I can go ahead and combine these two. 5x plus a negative 12. Right? These two, this 15x and this minus 10x combined because they're on the same side. Gives me just 5x. All right. Now, some people can stop right here and go, wait a minute. When will 5x plus 5 ever equal 5x plus a negative 12? People look at that and go, that will never happen. You are correct. This can't happen, right? Where they're the same. Let's go through the math anyways, and let me show you. If I subtract 5x from both sides, I get, the 5x's cancel, or all the x's cancel, leaves me with 5 equals negative 12. What? When does $5 ever equal losing $12? Definitely not the same thing. Definitely not. All right. So these are not equal. Therefore, there is no solution. Again, that means there is nothing I can put in for x in this equation that will make the two equal. All right. So it's not like you did something wrong. It's just there's no solution. And that sometimes happens where if I go back and erase this so you can see it, what happens is sometimes this never will happen. Those two sides will never be equal. All right. Excuse me. All right. Let's try the next one. A lot going on here, but take your time. Let's do it in parts. I'm going to distribute the 5 first. So I get 5p plus 15. Bring down the plus 9 equals 3 times p. 3 times minus 2, which is a negative 6. Or shushing it if you want, and you get plus a negative 6, right? If you shushing the 2. Plus 6. Okay. Right? This plus 6 comes down. On the left side, I get 5p plus 24. These two combine to give me 24 equals 3p. The negative 6 and the 6 cancel, right? It gives me 0. So I could say plus 0 here, but I don't need to, right? I don't need to say that. All right. Then let's bring the 5p over. I'm going to subtract 5p. So I get 24 equals negative 2p, right? I have 3 good guys, 5 bad guys. Means I have a negative 2 bad guys. Then divide by the minus 2 to get rid of that, to get the p by itself. So those cancel. So p is negative 12. All right, so we do have one solution here. This negative 12, if I plug it in for p, wherever it is, it will make both sides of the equations equal. Right? Any questions on that? Hope not, because I'm not there to answer them. All right, I have to pause a minute. I need to show you where Benny is. Let's see if this will work. Okay. See if my camera will pick it up. You see him right there, right by the stool there. He's sitting in the sun. You can see him. He loves sitting in the sun. Anybody that has a dog could probably understand and relate to that. I just had to show you that. Sometimes it's just so adorable. Okay, let's move on. Next question. Let's go to one like this. Uh-oh, it's a fraction one. That's all right. Don't panic. Here we go. Let's try it. 3 halves. Oh, try that in pen. 3 halves, or 3 over 2 has to be distributed both. So I'm going to do 3 over 2 times 8a plus 3 over 2 times 10. Right? This goes to both. Don't forget the -1. Bring that down with it. On the right side, I don't have to do anything at this point. Nothing combines, right? I'm going to show this part in a different color pen. I'm going to throw this over 1 and this 10 over 1. So I could show you why. 3 times 8, if I multiply straight across, is 24a. 2 times 1 is 2. That stays to the bottom of the denominator, right? Plus 3 times 10 is 30. 2 times 1 is 2. Then don't forget the -1 and the right side, 12a plus 14. What is 24 divided by 2? 11. No, that would be a mistake on my part. It is not 11. It is 12a plus 30 divided by 2 is 16. -1. Oops, not 16. Sorry, 30 divided by 2 is 15, right? -1 equals 12a plus 14. These two combine to give me 14, so I get 12a plus 14 equals 12a plus 14. Okay. What do you notice? I'm going to pause real quick. What do you notice about the left side and the right side? 12a plus 14 on the left side. Does that equal, question mark, 12a plus 14? Yeah, these two sides are the exact same thing, right? I actually can stop right here and I can say all real numbers. Sometimes as you get older into high school, they're written like this: R with a little line through it. Second line through it means all real numbers. What's a real number? Any number, fractions, decimals, negatives, positives. What that tells me is no matter what, any number I want to choose, I can put in for A on both sides and it'll be true. For example, somebody make up a number. Just give me some number. What? 3? Oh, okay. I heard you say 3. Then let's plug 3 in there, right? It's a real number. So I will put 3 in. What's 12 times 3 plus 14 equals 12 times 3 plus 14. This is 36. This is 50 equals, this is 36 and 14 gives me 50. Yep. 50 equals 50 always. Right? And if you can say always, then there means there's all real numbers. That's our answer. That's literally our answer, all real numbers. I can put any number I want into this equation up here at the very top. Whatever I want, I can put into that a fraction, a decimal, a negative, a positive, and it will work in this equation. Okay, so your answer is all reals. I want to show you, let's say you didn't realize this step right here. Bear with me a minute. I'm going to erase this. Let's say you didn't realize you were doing the work and you didn't realize those were the same. Watch what happens. I subtract 12a, I subtract 12a. I get cancel, cancel, 14, cancel, cancel, and on the right side I get 14. Oh, look at that. When does 14 equal 14? Always, right? 14 equals 14, so our answer is all real numbers. There's our solution. Boom, nailed it. Wow, there's a lot going on here. Okay, so let's back up. Okay. And let me show you a couple of things here. Okay, this equation, as you see it, I'm going to highlight it here in yellow. That equation, right? Do what we've always been doing. Carry it all the way through, do all the steps. At the end, if you get something where one side is definitely equal to the other side, then your answer is all real numbers, right? If we go back and go, wait a minute, here's a problem, and we work it through, boom, and we come down to, well, P is equal to -12. All right, well, then that's my answer, right? Only -12 can go in for this P, and it will hold true. Let's go one prior to that. Remember, we went through, we ended up doing the math on this one, and these 5x's canceled, so you got 5 equals -12. What was wrong with that? Does 5 ever equal -12? Heck no, it does not. That's why it never does. Therefore, there is never a solution, or there is no solution. You did not have an oops. You did not make a mistake in this case. It's just nothing ever works. Nothing will ever fill into this x and this x and this x to make it a true equation. Okay, so realize there's no mistake there, right? I know you thought I made a mistake, but I didn't. My mistakes have been to a minimum today. I've been doing pretty good, at least so far. All right, here we go. I would put this in your notes. All real numbers, in summary, when you say all real numbers, is when the variable is gone and a number equals itself. Could you have something like we did where you said 2t equals 2t? Yes. You know, if both sides are the exact same. But watch, if I divide both sides by t, I get 2 equals 2, right? That's why you can say the variable is gone. Or if you want, you can say where the left side and the right side are the exact same. Okay, then it's all numbers. It's always going to work. Always going to work. That's why we say all real numbers, no matter what, I can plug in, right? What if you get variable is gone, right? And a number does not equal itself. For example, 0 does not equal 2. 5 does not equal -12, right? Boom, boom. Hello, who are you sneaking in on us, right? Ta-da, da-da. They were saying, hey, good job. All right. Anyways, I get back to this. If they are not equal, that means not equal, then there is no solution. It will never with, oh, there's a mistake, never work. I almost spelled never wrong. It will never work, right? There is no solution in that scenario. All right, hopefully you got those down. Okay, here's the QR code, of course. Go ahead and scan that. Tell me how many mistakes I made today. And then don't forget to talk about the sticker on my head and what that maybe the point of that is in your journal today, and write down how many mistakes I had in the journal today. And you could say, how many times did you see Mickey Mouse? All right, everybody, hopefully you scan that QR code, right? Stop share here. Everybody have a great long MEA weekend. Thank you for being such respectful and honorable students. I hope, right? I don't want to come back and have a negative report. Guys, be respectful, please. Get work done today. You have class time to do it. Get it done. Make sure you go back and get the other 2 assignments done if you haven't done it. Again, you can't get any better if you don't practice, right? Don't think of it as homework, but think of it as practice to get better. You can see that each day it got a little bit more difficult. So if you don't practice, you're going to get really stuck really fast. Go back, get it done, submit it into Schoology. This video is in Schoology. The worksheet's in Schoology. So if you need to go back and rewatch this video and pause and rewind, by all means do so, right? All right, everybody. Thanks for your attention. And I hope you had a great week. And I hope you have a great upcoming long weekend. Miss you guys. We'll see you on Monday. Over and out.